Welcome, TC Oceanography, to our third video in the series. This musical guest is Chen Chen with whatever song it is. I went into YouTube and Googled movies about water, and this is what I found. The movie is called Water. A little jam, a nice little. Anyways, I digress. So anyways, this last part of our first chapter is about water. My prop are those you had me for bio. These are our magnetic water molecules here, so we can try to build those. And so this should be a quick review. If you remember about water, a water molecule, H2O, hydrogen, two hydrogens, attached to an oxygen, being a polar molecule. And if we see here, and that's going to be kind of tough, the charges, but there's our water molecule, and so this would be two water molecules. So this is not as exciting as the shark, I know, but trying to make water fun. So here would be a whole fistful of water. So anyways, water planet. So this one, so when we talk about water planet, we got to talk about a couple things. So that when we talk about water as a planet, we need to talk about the planet. Some factors that affect the shape of the Earth. We do talk about gravity. And gravity is why Earth is nearly spherical. So it's not a perfect circle, maybe what you had to draw in elementary school. There is a spin, and so as it spins, it's causing that bulge at the equators. And so if you think of Earth as being a sphere, and as it's spinning around, right, it's going to bulge out at the equators. Then we have distribution of continents. So the way those continents, a slight pear shape, and then you have topographic relief, minor compared to planet sizes. So there's a lot going on in the Earth's shape. And so often some of the renditions of the Earth that you see in textbooks and those kind of things are not necessarily accurate. But gravity gives it a spherical shape. The direction of the spin, and as it's spinning, again, it causes a bulge at the equator. How the continents give it a slight pear shape. And then you have topographic relief because the distribution of the continents, most of your land mass is found in the northern hemisphere, and a majority of the water is found in the southern hemisphere. And so that will kind of give you that pear shape, but we'll talk about that. No one ever wants to be called a pear shape. It's not. Sorry, Earth, if I'm giving you issues right now. So where on Earth are you? Right now I'm in Tiffin, and I should probably look up my latitude and longitude. But when we talk about latitude and longitude, I don't know where to put my face. That'll work right now. Measured in degrees, minutes, and seconds. So 1 degree equals 60 minutes, 1 minute equals 60 seconds. And so when we talk about latitude and longitude, we'll get more into this in a later chapter. In the nautical mile, NM, 1 nautical mile is equal to 1 degree of arc length of latitude, and 1 nautical mile is equal to 1 degree of arc length of longitude at the equator. I'm not going to get into calculating nautical miles right now. If you ever spent time on a boat, nautical miles are important. Like I said, I spent a month at sea. And so a nautical mile is not necessarily equivalent to what you think as a mile. So latitude and longitude, latitudes or parallels. Again, the lights went out. I gotta stop doing this. All right, and I'm back. We'll figure it out. So latitude and longitude. Latitudes or parallels are parallel to the equator. So 0 to 90. Positive goes from the equator north, and then 0 to negative 90 is your degrees to the southern hemisphere, and we'll talk about that. And then longitude, or your meridians, are those ones that go the right angles to the latitude lines. Now again, the Earth is a sphere, so here's my latitude, here's my longitude. Think of like a long, right, a long line. So this is latitude and longitude. And your prime meridian, Greenwich, is measured from that prime meridian. So from 0 to 360 degrees east from the prime meridian, or 0 to 180 degrees east and 0 to negative 100 degrees west. And so this is where you get the international date lines and the great circles. So latitude, parallels, right? Equator, you've got your Tropic of Capricorn, Tropic of Cancer, those kind of things would be latitudes. Longitudes are based on that meridian, and they start from the prime meridian, and they go from 0 to 360 east of that prime meridian. Or you can say, if anything's positive, it's going to be east of that prime meridian. If you see anything that's like a negative, or is a west. So if you look here, where on Earth are you? Here's your parallel latitude. So here's our equator. This is 20 north, 40, 60, 80. 20, 40, 60. So there are your parallel latitudes. Here's Greenwich, which is the prime meridian. So Greenwich, England. And then if you're going east, east, west, I was going the wrong way. So this is your prime meridian. And so these would be your, again, longitudes. And then if you do like a cross section here through the earth, again, there's your latitudes and longitudes. There's your equator with your latitudes. And then you can see like 30 east, 30 south. And so a lot of times when those numbers are given, you can pinpoint a location based on latitude and longitude. So measuring latitude, if we look at the North Star or Polaris, which is its name. So the North Star, 90 degrees north latitude. And if you go here, depending on where you're at 90 degrees north latitude, right, you'd measure the angles. We're not going to get to that in this course, but just showing you that the North Star, often when you hear about the North Star, that is your guiding spot. Longitude and time. With longitude and time, use of clocks record the time. The sun is at the zenith, so you're looking up, that's where your sun is. And so when we talk about Greenwich Mean Time, GMT, that's your universal time. And so basically what happens is when we're looking at time, and again, time is a human construct, the Earth rotates about 15 degrees of longitude each hour. So every hour, we're moving about 15 degrees longitudinally, okay? And so that's how when you're looking at the sun and you're trying to determine time. I'm not real good at this, but this is one of the ways that we can do that. So if we look at time zones here, and again, I'm going to move my face up here. If you've ever traveled, especially from west, so like going to China or Korea or Thailand, you notice that you kind of like, it's like they're 12 hours ahead, you know, when we talk about jet lag, and then coming back, you like gain this day. And so if we look here, countries where standard time differs half an hour from neighboring time zones, and then countries and areas where they have not adopted a zone. So it's interesting, if you look down here, here's Greenwich, here's our prime meridian, if that's 0, if we go east, hour ahead, 2 hours ahead, 3 hours ahead, 4 hours ahead, Earth's not flat, this would be a circle, or sphere, bulging at the middle, 5, 6, 7, 8, 9, 10, 11, 12 hours ahead, right, when you get to this international time zone, dateline. And then 11 hours behind, 10, 9, 8, and so on and so forth. And so those are how those time zones work. And it's interesting if you ever do get to travel through another time zone, the jet lag does affect you. A lot of this is based on, the sun. It was interesting in China being such a large country, they're all on the same time zone, whatever Beijing time is. And so let's talk about Earth now as a water planet. So water on Earth's surface, it does affect the seasons. So water does have this ability to affect seasons. And so the fact that 71% of the Earth's surface is covered by water and only 29% of surface area is land, that does cause seasons to occur, especially because water retains a lot of heat. And so the fact that it retains all that heat, right, it takes a little bit longer to cool down. And so that's why often the water in the Lake Erie will be much warmer into colder months than, say, other bodies of water. So water does retain a lot of heat. So water on Earth's surface, 71% of Earth's surface, again, covered by water. Most of that water being in the southern hemisphere. 29% of the surface is land, which is found in the northern hemisphere. So we talk about the water cycle or hydrologic cycle, evaporation, transpiration, sublimation, precipitation, rain, snow. You guys have learned about these before. I'm not going to hammer away at the water cycle. But there it is. There's your hydrologic cycle. And so we'll talk more about this. But as temperatures increase, you have more evaporation, condensation, it cools, and then it'll fall. And then we'll talk about rain shadows and those kind of things as we talk about how mountains affect rainfall. So what I do want you to know about what a reservoir is and residence time. So a reservoir is a area that stores water. So there's the Ogallala Aquifer. So think of an aquifer. You may not have heard of one before as a reservoir for water. And residence time. Residence time is how long it'll be there. So a large reservoir, long residence time. Small reservoirs, short residence time. So if you look at this graph here, so a 55-gallon drum, if that water stays in there, it's a large reservoir, has a long residence time. It would take a long time for that water to dissipate or disappear. you go to the eye of a needle, if we just put a drop of water onto the eye of a needle, small reservoir, small residence time. And so residence time is important when we talk about pollution. So here's the approximate water volume on Earth. And so oceans and sea ice, we've got in cubic kilometers, right? Miles cubed, and so approximate percent. So ocean and sea ice, about 97% total water. You got ice caps and glaciers, groundwater, freshwater, saline, lakes and inland seas, soil moisture, atmosphere, and then rivers. So the total water volume is 332 million cubic miles, or 387,897,150 cubic kilometers. There's a lot of water. And so when we talk about distribution, I already talked about this. The northern hemisphere is made up mostly of land mass, and the southern hemisphere is water. And that's why when the Earth spins, you have that pear shape, because there's a lot more water in your southern hemispheres. And here's your 5 oceans, not 7 seas. Pacific as being the largest. We go Pacific, Atlantic, Indian, Southern, and Arctic. And so if you look at the Pacific, you can look across. Again, I'm not going to expect you to like memorize any stats here, but when we look at you got the area, percent of surface, the volume, the Pacific makes up is over half of the volume of ocean water. The average depth in terms of the Pacific, again, 3,172 meters. And so I think that is probably the part of the deepest is the Pacific. And then there's your maximum depth. And this is just kind of showing you your 5 oceans. So, all right. So that was just kind of an overview of the Earth as a water planet. We're going to put back on the song. I got the spinning wheel of death here. So this again is Water by Chan Chan, Water Molecules. So what I tell you to do, the takeaway from this is just understanding what the water cycle is, your 5 oceans, and this hopefully is just kind of a quick overview. So again, if you got any questions, let me know. Have a great day, and this is me signing off from 102 on Tiffin's beautiful South Side.